Yeah, guys, today our topic is first hope redundancy protocol, that is FHRP. So here I'm taking some example. Before that, we'll discuss if FHRP is not there, it is our one of router in R1, and it's a ISP, internet service provider, and with internet you are connected with cloud or Google something. Internet, it's a internet, like it's like internet. Now you are having one LAN connectivity with LAN connectivity, like, and here connected with multiple users. See, it's a branch. They are connected with multiple user, connected to this two-tier architecture. This one is a switch. Okay, it's a core switch. Okay, now which were access or core switch, distribution switch. Leave it now. Not that point, but see, this user, this PC, this host wants to communicate internet, any random IP, like Google having 8.8.8.8. So Google only, he wants to connect google.com. Then Google having IP address is 8.8.8.8. Now, the if now everything is fine and fit working, he is in some VLAN, the reachability, he will reach to the gateway. It's a gateway of this end users 1.1, can assume, or 1.1 IP address is gateway, and they are in /24 values up to everything is fine. Is the way IP address of this PC is 1 dot something 10. Everything is working fine. Once the link goes down, here we have a problem. Like our entire host cannot able to reach the Google, or they cannot able to reach any applications. If they want to connect some office with they are working from home, then they are working from home, so they wants to communicate with the help of internet. Their office is in different location. Now we have like a remote home applications also. With the help of VPN we can able to reach, but once the links goes down, what is the issue? They cannot able to reach. So we have another option. Then we'll take another ISP2. Fine. With the help of ISP2, our problem will be resolved. We can able to, this branch can able to reach internet because we have a redundancy. Fine. If the redundancy is there, once this router also went down, you can assume that now both links are working fine. Now this link are also working fine, and this link also working fine. Okay, now in this time the problem is with this router is went down. Then again the issue, these end users cannot able to communicate internet or any application, they cannot able to communicate. So the issue is there or not? If no redundancy, if redundancy also is there, if redundancy router also not there, means issue with, here we have issue. So how will we will reduce, how we will overcome that issue? How we will overcome that issue? So if router also goes down and if this link also goes down, the issues are there. So we have solution for that. We have a solution, that is FHRP. How will overcome those issues is now we'll discuss. Anyone have any questions till up to here? You can assume like this is the a 1 Gbps link, 1 gig link, and this one is like 100 Mbps link. Okay, Mbps, because we'll use like this one as the primary. Now in this case we'll use as a this one is the primary, because we are paying something extra through this link, because we've planned to overcome with the help of FHRP. That time we'll use as a like a redundancy part, then we'll pay less amount for this link and we'll pay extra amount for this, because we are getting the 1 Gbps link and we are getting the 100 Mbps link. Okay, fine. After then we'll if you have any queries till now, anyone have any doubts?
No, good.
Fine. See, now FHRP having 3 types. First hope redundancy protocol having 3 types. First one is HSRP. HSRP, hot standby redundancy protocol. Hot standby router protocol. It's a redundancy, sorry. Mistake. It's a redundancy. Can write here. It's a redundancy. And second one is virtual redundancy, router redundancy protocol, and load balancing. There we have 3 types: hot standby redundancy protocol, and virtual router redundancy protocol, and gateway load balancing protocol. This is the Cisco and this one is the Cisco. It's open standard. Open standard? No. Well, see, first hope redundancy protocol. Redundancy attempts to eliminate single point of failover by providing guide duplicate devices and links. It means here see, if it's a redundancy, we are using like 2 ISPs here, ISP1 and ISP2. That time in this case, if one link goes down, then we have a other link. But here we have a problem, like if the router goes down, then these LAN users cannot able to reach internet. So now we'll use like, we need a solution for that. We'll use a 2 routers and 2 ISPs. Or you can use 1 ISP also, no issue. I'm taking as a 1 ISP. If 2 ISP is there, then that is better. Okay. If 1 ISP went down, the second ISP will have, we have likewise the connectivity, like it will be. It will be having likewise connectivity. Here will use for this interfaces. Likewise, it's a three-tier architecture. It almost in data center will use this kind of architecture. Now come to different architecture we'll discuss here. This is one ISP, only taking as only a one ISP, and here we have two redundant routers, R1 and R2, and they are connected to one LAN, and LAN having multiple users. In this case, how we'll use the HSRP or VRRP? We have three types of protocols here: hot standby, redundancy, and virtual. HSRP, VRRP, and GLBP. So this is our LAN. Up to here, our LAN. In LAN connectivity, we'll use same network. Here we'll use like same network because of whenever you are applying any redundancy protocol, you are using like virtual gateways. Okay. Before that, here I'm using virtual gateways. I'll come to that point. 1.24. This is the one interface. That's one physical interface for this gateway. This is the gateway of this interface. You can assume like this one is F0 by 0. And another port is connected here, F0 by 0. And IP address is like for this interface 192.168. Same network we should have to take, because I'll come to that point. See, and these are the same network, means the this host havings like 192, whichever 168 1.10 IP for this interface, and for this user 1.20 for this. You can assume like this. They having two hosts. They wants to communicate this ISP. So what is the functionality is there? Then this act as like gateway for this router, and this is act as like one of the gateway for this interface. In earlier, in past lab, in before whichever we did OSPF, EIGRP, RIP protocol, we have taken only one router. That router is connected to end users, like this is the end user, like everything is connected to likewise only. They are connected likewise, and end users are multiple end users. So only we taken only one gateway here. But now we are taking here two routers, because if one fails, if this router fails, we have another one router, because we don't want to waste our client time. Because if link goes down, the business hours, they maybe they will get issues. They will not get applications, means it will be take effect to us. Okay, business hours, if internet is not there, means it is not good in organization. So we require a redundancy. Here we have a redundancy. So in this case, we'll use as a, for this interface, if we take as a gateway for this router, gateway for this router, gateway for this router. How to assign the gateway, everyone knows, I think. In past we did the lab, gateway is required for this. If we assign only one gateway, the traffic will be go likewise. If this link goes down, then the issue is there. So we need a virtual gateways here. Virtually, we should have to apply the virtual gateways like 192.168. One dot you can take as a gateway like 100. Same network. You should have to take as the same network. Then with the help of this virtual gateway, if this link goes down also, with the help of virtual gateway, we can transfer our traffic with the help of this gateway. Understood? We are not applying any load balancer here. Just if link goes down, this router goes down, if this link goes down, we are using this link now. That is, we call it as a redundancy protocol. This is all about FHRP. Here we have three versions and three types of virtual redundancy protocols. The same functionality everyone having, but the difference of these protocols are. Any doubts in FHRP? Guys, any questions?
No.
Good. See, HSRP, VRRP, and GLBP. Here, scope is HSRP, Hot Standby Redundancy Protocol, and GLBP, Gateway Load Balancing Protocol also. These both are in Cisco proprietary. And now open standard is VRRP. This will be applied in Cisco devices, this one and this one, but open standard is VRRP, and almost they will use VRRP only in every organization, for my point of view. Now, and which one is load balancer? Or which one having load balancing? Only GLBP will do the load balancing. This one is no. HSRP also we cannot apply the load balancing, and we cannot apply the load balancing in VRRP. Load balancing means this is the end users having. Here we have a two ISPs, ISP1 and ISP2. We will share service traffic from this interface also. Will share traffic from this interface also. You can assume like here we have another router like here we have redundancy like this one, and our ISP will use at a time R1 and R2 both routers. Even though we can apply the load balancing in this also, that different method, but by default load balancing will be happen in GLBP only. If you want load balancing in VRRP and HSRP also, we can do it. We'll discuss, that is advanced topic. But if we can apply means, yes, we can do the load balancing in HSRP and VRR. By default, only GLBP is the load balancing protocol. And the multicast group IP address. The multicast IP addresses are like HSRP will use 224.0.0.2 for version 1 and 102 for version 2. There we have two types of, with the help of multicast IP address, they'll share the information. They share the update. They share the any changes occur in if occur in the topology, they'll share with the help of multicast group IP addresses. Then VRRP having 224.0.0.18 and GLBP having 102. And see here version 2 also same multicast IP address, and GLBP having same multicast IP address, because both are Cisco proprietary. Don't forget, GLBP and HSRP both are Cisco proprietary. That is the reason they are using the same multicast IP address also. Fine. What is a port number? UDP port number. Everything having UDP. What is the difference between TCP and UDP? Pawan?
Yep.
What is the difference between UDP and TCP protocol?
So
Ajay?
Yeah, for the TCP protocol, it is a connection oriented, and the user for the UDP, it's a connectionless. It supports the acknowledgements, and it does not the acknowledgements, and it is a reliable communication protocol for the TCP, and the UDP is an unreliable protocol.
Good. Saisri, protocol numbers. Do you have any idea? UDP protocol number and TCP protocol number.
Yes. Yes. For UDP it is 617. For TCP it is 6.
Fine. For reliability purpose, any process is there for reliability? For what is reliability? Yamuna?
So for reliability purpose, it uses the three-way handshake method. So once the client it gets the acknowledgement from the server side, then only it starts sending the messages.
Fine. See, multicast group IPs. Sorry, this is a not multicast group IP. The port numbers. Port number. Okay. The UDP uses port number that is 1985, and that is HSRP, and VRRP having port number is UDP port number. It will be used 112, and UDP port number GLBP for the 322. Fine. With the help of port number, what we'll do in ACL, we have two types, standard and extended. Standard in ACL means they'll use as like only IP addresses. With the help of IP addresses, we can deny or permit the any traffic. We can deny or permit. But extended ACL, we have a same will use IP with the help of IP addresses. We can deny or permit the traffic. Plus we have one more thing, will use as a port based deny or permit the traffic. Whenever you are using in ACL, that time if you want to traffic here, I told you here we having it's a gateway protocol. There we have multiple users, like you can assume for this user, this user connected to ISP. In this case, with the help of port number, we'll use, now we are using here HSRP. It means we'll use as a 1985 port number. 1985 port number. We'll create one policy. In that policy, will tell that for this end user should have to use the way of this path. For this end user, use the path of this path. With the help of ACL, will play with ACL these port numbers. Deny or permit or apply the policy, which policy he'll use, those things will use with the help of ACL with these port numbers. If you are using HSRP means you'll use this port number. If you are using VRRP, you'll use these port numbers. In ACL will apply. Access control list. When we discuss ACL, you can understand those things. Understood? With the help of port numbers, what we will do. And even though not in ACL, In firewall also we'll apply the policies same likewise. In policies also we'll use like protocol number, and port number to identify the service. With the help of port numbers or protocol numbers to identify the service, which service of that. And if you are using port number means it won't use in 112 for the applying for the VRRP. It means that it will be unique for this. We cannot apply in this 112 for different protocol. If you are applying for this, the firewall and ACL, every protocol will understand the port number is coming. The traffic means that is the VRRP traffic. They will assume like that is the VRRP traffic. They knows everything. It's a standard value of the protocol having. Fine. Any doubts? What is the use of port number or protocol numbers? Now move forward. What is the timers? See, in timers, HSRP will use 3 seconds for the hello timer. It will send his neighbor, whichever redundancy neighbor is there. It will be sent if I am alive. If I am if the die means this will be down means it will be wait for 10 seconds. If every 3 seconds it will be send the update, I am the alive. If in after 3 seconds this R1 will not send to the update to this router, then R2 will assume the R1 is down. Then it will be take as a master. Here we have active and in this case active and standby policy. In this case master slave election will be happen. Master and slave. Active and backup. In this case active and standby. HSRP will use as states active and standby, but in VRRP will use like active backup router. This is one active router, and this one is standby. Okay, if every 3 seconds R1 will not send the update, then R2 will understand the router is down. Then the standby router will become active. It will become a active router. Then it will take the every responsibility to it will be pass the traffic to internet. If this router will goes down. If once this router will be come up, then we'll use like here preempt option. Then once the router will be come up, then it will become up with the help of preempt. We will discuss that. And now till now, anyone having doubts? Active and standby. And which one the active router? How it will be elected? Based on the highest priority. First, it will be based on the whichever the router having the highest priority. By default, every router having the priority is 100. This router also having priority like 100, and this one router also having priority like 100. Now, how they will elect? Then it will be see the highest IP address. If this one are having one IP address, then this one is having 2 IP address. Then whichever having highest IP address, based on the highest IP address, it will be select as a priority active router. The tiebreaker is highest IP address, whichever having. And see here also highest IP address. And gateway also. And in this virtual gateway, the process is different. Like there you'll use up to 4 or 5 routers. Those are every router will use the load balancing. Means if this is a 10 Mbps link, this one is 10 Mbps link, this one is 10 Mbps link, this one is 10 Mbps link. We and user initiated some traffic like 80 Mbps file he initiated means 10 Mbps for this, 10 Mbps for this, 10 Mbps for this, 10 Mbps for this. Understood? The load balancing will be happen here. Equal cost load balancing it will take. Fine. Now, but GLBP in organization they won't use. No, they will not use. Either they will use HSRP, either will use VRRP. But mostly organization at 60%, 60 or 70%, they'll use VRRP only. Most organization. Understood? Because of it's an open standard protocol. Apart from that, we'll use load balancing, both of this. How we'll use mainly load balancing. See, you having two user. This user is VLAN 1 and this user is in VLAN 2. VLAN, virtual local area network. Then that time we'll use like for this VLAN for virtual gateway is different for 160 for this one, 150 for this one. That time 150 will apply, 160 will apply for this virtual gateway, 150 will apply this gateway. But in this case, only for VLAN 10, one part we are using one interface only. This is for standby for him and active for him for this. Here also we are not using for load balancing for each one use one for particular one VLAN. We are using as active all the traffic. If in this VLAN we have it like 250 pieces, it means this all the pieces will move likewise only. If this pieces here we have 250 users means they'll move likewise only. If this went down for this active part, it will move to this likewise. You'll use likewise. Understood? But in load balancing this not likewise. In GLBP we'll use like every port, every interface we are using. Now election will be finished. Any doubts in election? How the elected as a active router, how the elected as a master router? Guys,
it's good, Nalin.
in HSRP, what is HSRP? What is a HSRP?
Hot standby.
Like hot standby router protocol.
Okay.
Hot
Okay.
standby redundancy protocol.
Good, whatever. Hard standby redundancy router, but that is my mistake. I wrote here that, but it is redundancy protocol. Don't confuse it. It's a redundancy protocol. Fine. Tell me about HSRP. Something brief about it. HSRP.
It's a Cisco proprietary and doesn't support any load balance. Its multicast IP addresses are 224.0.2 for version 1 and 224.0.102 for version 2. And its port number is UDP 1985. And the for the hello and receive timers are 3 seconds, and the whole timing was 10 seconds. For the router protocol, the routers, first one will be active, and one or more will be on the standby state. And it will be elected based on the higher priority. If it's tied, then it is elected by the highest IP address.
By default, priorities.
Default priority
100.
100.
Good. Fine. Anyone have any queries? Until what we discussed? Good. See, one active router, one standby router, one or many listening routers. See, if we have multiple routers, means see, one is active for this ISP, one is standby. If any other routers also is there, those are listening states. We have like first one is active, standby states, and listening state. If this one is listening state, if this goes down, then it will be active, then this one is standby. Okay, and in this case, one is active and one is backup. Whichever all the routers are like backup, it will be select again based on the highest IP address. If priority match, then they will elect as a based on the highest IP address. And here the concept is like different. One AVG active virtual gateway up to 4 routers. These all are the 4 routers. All are the for will share as a gateway like for everything. These are the AVG router group active virtual forwarding passing traffic up to whichever up to 4 routers will use. If we have multiple routers, those are active virtual forwarding groups up to 1024, this many routers per physical interface. Fine. Up to here, okay, fine. Now what is preempt? Preempt by default disable in HSRP, and in VRRP by default it is on. If active router is down and up again, it will be automatically become a master. See, what is the mean by preempt? This is our LAN. Fine. If this link goes down, this one active, this one standby, then active become a down. If the standby will be become a active. Once likewise, if this link goes down, they can assume, because in our LAN we are which interface will apply? Actually, we will apply for this interface. Whichever HSRP we are applying, not for this interface. Guys, please listen carefully. Whenever I am applying HSRP, I'll show you in lab for that. See, I have lab here. In this case, for preempt, how it will be work? I will apply, this is my LAN interfaces. This is my WAN interfaces. You can assume like this is my WAN interfaces. This interface will down. Then this will act, standby router will become as a active. This router down, standby will become as a active. But if this link goes down, then what is the issue? How we know? That is the WAN link. We can assume like in LAN network will configure as a for this interface only we are applying HSRP virtual gateway we are applying for this interface. But in this location we are not applying. If this link goes down, how we know? How we know? There we have a tracker. Track. With the help of tracking, we'll know the issue. Will apply tracking up to 30 seconds, or if this link goes down, the traffic is not sending in this link, up to this link, wait up to 30 seconds. This user is not getting any reply, then it will be sent through this link. This will be active. Likewise, we have a tracker. But again, this link will be come up. Okay, this link is come up. Then that time we have an option like preempt. Preempt, what it will be do? My earlier I was down. This router will inform to this router. Earlier I was down. That time I was a active router. Now my status is standby. Please refund or give me back my active status. This router will ask to this router. Then this router will give back to this router role, whichever you earlier you have, take it back your role. With the help of preempt, it will be happen. By default, in HSRP, the preemption is disabled, but in VRRP, by default, it is enabled. Guys, understood what is the preempt?
Yes.
Can anyone explain what explain? Anyone? What is the
Like yeah, go ahead.
Like in HSRP, like the preempt is by default it is off when the router is like when the router is not working on the when it is gone, and the router 2 it will be active, but it doesn't know like when the router is 1 is on or no. It doesn't come to router 1 until and unless the prompt is on. When the prompt is on, it gonna know, it gonna change to router 1 and router 2 will be like standby.
fine. That
In
that also
HSRP.
ISP interface. Good, but
Yeah,
that is a ISP interface. It's ISP interface. Okay, this is our
yeah,
ISP interface. This is our ISP
yeah.
interface, and this is our LAN interface. Will apply will
We'll
apply
apply.
up to here only. Okay.
Yeah,
In this interface
it
only we
apply
are
in LAN
applying the
interface.
we are applying HSRP up to here only. We are not applying
Yeah,
for this interface. Whenever you are enable the preempt, it will be rolled back to whenever this went standby. Whenever this interface goes down, it will be moved to the standby. And once this router come up, the highest priority and highest IP address, it is elected as a earlier. It is a active router. Now it is that time it's a standby, but it will be came up that time this active goes to the standby. Then the router will be give to roll back to this router. Understood. That is the reason of we should have to enable the preempt. With the help of tracking, we can whenever you are applying tracking, just give us some seconds. That configuration is likewise. How we'll configure it? I'll show you the basic configuration. First, we are applying standby likewise. It's a virtual interface and it's a group IP, and priority will give priority if you want to change that router, whichever having highest priority, that router elect as a active router. Then if you if you want to enable the preempt, just to give us likewise. And tracking means if it will be track whenever the interface goes down, it will become 30 seconds. If not getting packets, then it will be go to the automatically standby status. This is our configuration. We'll do the lab, don't worry. Before that, our theory part finished. Fine. This is a preempt and virtual MAC. Here we are not using MAC addresses. We are using like virtual MAC. With the help of virtual MAC, we'll identify the which group is working. With the help of a MAC address only, they'll send the layer 2 updates, L2 updates. With the help of multicast IP address, they'll send the L3 updates. Here we'll use L2 update for the MAC address. It's a multicast MAC address. And IPv6 support VRR HSRP and